Next up, we can come to the first really interesting part, where we are creating the overworld, which will be the first proper level. And for all of that, we don't even have to create a lot of logic. We just have to place a whole bunch of elements. Although first of all, we have to do a bit of setup. This game scene is going to be the parent for all of the level scenes, which means it should only contain the absolute minimum, which at the moment means we don't want to have any of this terrain. I want to get rid of that entirely, meaning all of these boxes shouldn't be there. So delete. Then the player is floating, which is fine for now. Instead, I want to create a node 3D that I'm going to rename to terrain. For the actual levels, this node will contain all of the environment. Let me place it next to the character, and we can put the pickups in there as well. It just feels a bit cleaner, but the order here doesn't matter. Also, while we are here, we can close a whole bunch of scenes. We don't need the character, the player, the skeleton, the inventory, the stored, or the pickup. We really just need the game. Once we have that, we can go to Scene, New Inherited Scene, and the parent scene should be game.tscn. This I want to open, and then rename game to, let's call it Overworld. Save this one as well as overworld.tscn, and then we have a scene that we can work with. We're going to add things in just a second. I just realized there's one more thing that shouldn't be there. Inside of pickups, we don't want to have any pickup right now, but we do want to keep the pickups node 3D. So at the moment, this is all you want to have inside of the game scene, where we have lights, a node for the terrain, characters with the player. The player should be in basically every scene. Then we have a node for the pickups, for the HUD, and for the inventory. Once we have that, we can work inside of the overworld, and really all that we have to do is add stuff to the terrain node 3D. For that, you want to go to graphics, and in there we have objects. That folder is going to be the center of this video. Most importantly, the file you want to look at is called overworld_environment. If you double click on that one, Godot is going to load for a second, and then you should be seeing the overworld. This is going to be the main graphic for the overworld. And really nice here, when you look on the left side, for example for these rocks, we have the mesh. This is what you actually see. On top of that, we have a static body 3D with the collision shape. This applies to basically all of them. And because of that, we don't have to worry about collisions. On top of that, what I also want you to pay attention to is the layers. The terrain layer in this project is layer 1, and that's the default one. Basically, for the terrain, you always want to have layer 1 because, well, you're mostly working with terrain, and having this on layer 1 makes your life much easier. Now, before we continue, here is the file in Blender, which is where it was created. And the reason why we are getting collision shapes automatically is because when you look at the names, for example, for these rocks, we have the name rocks and then -col, short for collision. This tells Godot when it is importing this file, it should add the collision shape right away. There's also a sun, although this we don't want to have in our project. Which means, back inside of Godot, I want to double click on the overworld environment again, then click on the sun and skip import. Now we can re-import the entire thing, and then drag and drop the overworld environment inside of terrain. And then we have the overworld. And collisions should be working already. So let's try this one. The player is going to fall, that's fine, but now we can run around, and we have the overworld, which is looking significantly better. So this part is already working. We have the lights, we have a camera blur in the distance. All of this was set up in the first part of this course. Alright, I think a good start position for the player would be somewhere up here. There we have the tunnel. Let's try that one. So there we can see the entire overworld. We can go on the tunnel, which should also have collisions. It's always good to double check. And we do. This is working really well. Everything else also seems to be going okay. The menu, we can change weapons. And alright, massive progress. And on top of that, if you look further inside of the objects folder, there are a ton of objects that you can very easily add to the scene. For example, we have barrel.glb, where we have the barrel mesh, and we have a static body right away. Which means all you have to do if you want to add this thing is you drag it into the game, and then you have a barrel. It's literally as easy as that, and I think looking at this, the player should be a bit further down. Roughly here. And now, inside of the game, we have a barrel, we have collisions, and that's really all we need. Now, not every single object inside of these files has a collision shape. For example, I think the bridge doesn't have one. This is just a mesh. And I guess to test this one, let me zoom out just a bit. Later on, inside of this canyon thing here, we are going to add water, which means we want to have the bridge somewhere there. Let me place it somewhat reasonably. And by the way, if the camera zoom gets weird and you can't go in any further, click on perspective and then orthogonal. Then things are going to get a bit weird, but eventually find the place again and you can zoom in much more easily. Let me move the bridge roughly here and here. Yes, this should be okay. Now to test all of this, I want to grab the player and move her next to the bridge. Here-ish should be all right. And also be really careful with the setup. I have added the barrel and the bridge to the characters node 3D. They should be inside of the terrain. Let's try this again now. And inside of the game, we have the bridge, but this is an illusion. I can walk right through it. That happens because the bridge doesn't have a collision shape. And let me zoom in just a bit more so we can see it. There we go. Now, if you want to give this object a collision shape, you don't have to do very much. Simply have to go to the bridge and then editable children. Then you can get the mesh itself. And once you have that selected, you can go to mesh and then create a collision shape. You want to create a static body child, and then you can select one of these meshes. Prime mesh is usually fine. Create that, and now you have a collision shape. That was literally it. If I now run this scene again, inside of the game, I can jump on the bridge, and we have a bridge. This is looking really good. All of the other collisions work as well, so I am really happy. And well, at this point, all you really have to do is to populate this entire area with stuff that you find inside of the objects folder. This isn't a difficult process, you just have to drag and drop stuff in there. And most of the time, you want to have the terrain node selected and then drag things right in there. That way, Godot is placing it right on the grass, which helps a lot. And that is bringing us to an exercise. I want you guys to create the basic overworld level, which basically means just place a whole bunch of stuff in the level and make it look nice. That's all you have to do at the moment. I skipped ahead and placed a whole bunch of elements. Mostly trees, to be honest. Besides that, we have a castle, and that is pretty much it. If you look at the terrain node, we have the environment, a bunch of things, and then, to be honest, mostly trees. I put them all inside of one node, which is incredibly long. I don't even want to open it, but you get the idea. With that, I can run this scene again. And I think we have to place the character a bit lower at the start. But now, if you look around inside of the game, we can go to a forest and look at a whole bunch of trees. We also have collisions, and that is working pretty well. And I realized I made a bit of a mistake here. That can happen very easily. But other than that, creating this kind of overworld really is just an effort thing. The more time you spend on it, the better it's going to look. Also, I forgot to mention earlier, if you want to zoom in on one object like this tree, you just have to press F. Then Godot zooms in, and you can place things much better. Cool, with that, we have the overworld. While doing that, I want to go to Project and Project Settings, and then when we are running the game, I don't want to run game, I want to run the overworld. That is really important because if we are starting inside of game, then let me run it. You can see it really fast. We are just falling, and that's not fun. To make the overworld feel more alive, I want to create some water. The standard way of doing that is to use a spatial shader. And in our case, this shader we are also going to reuse for the lava later on, because both are liquids and we can kind of make this work. Now I know shaders are more advanced and they can get quite finicky. So for this shader, we're going to start with the visual shading language. I think that's a bit easier to understand. Back in Godot, inside of terrain, I want to add another node, which has to be a mesh instance 3D. This I want to rename right away to water. And then we have to place it. Now at the moment, this mesh is not visible because we don't have a mesh. The mesh I want to work with is a plain mesh. And let me move it just a bit over here. Zoom in. You can see we have basically a plane. That doesn't do very much at the moment, but that's fine. That's going to be done via the shader. First of all, though, we have to place it properly, and I want this thing to cover the entire canyon here. To get that, you want to work with the size and increase these numbers a lot. Let's go with 400 by 100. Then it's becoming much more visible. Still not large enough, but now it's easier to place. So roughly here. Then we can make it wider. I guess we can go with 600 and maybe 200. I guess that works reasonably well. The really important thing is that we have to cover this thing end to end. So there has to be water here, and we need to have water here as well. And that looks all right. Besides that, for this water mesh, we need to have a lot of vertices. At the moment, we don't have very many. If I display the wireframe, we can't even see it because we don't have enough. We can really only see the overworld. To improve that, I want to add a lot more subdivision width and depth. That way, you are getting a lot more, and eventually we should be able to see this. You can kinda see something happening there. Let's go with 300 and 100. Now you can see there we have a white-ish mesh that we can animate using a shader. And it's a bit more visible here. I hope the video compression doesn't make this invisible. I guess let me go back to normal. Then at least we can see the water. But the really important thing is this thing needs to have a lot of vertices because these vertices we are going to move up and down using a shader. For that, we need these subdivisions. Without that, this wouldn't work. And I think we can move the water up by just a bit. So it covers a bit more of the bridge and the pier. I think that looks better. But once again, just play around and see what you like. In my case, the really important thing is that we are giving this thing a material that has to be a shader material. Then you can create a shader, new shader. We want to have type visual shader, mode spatial, and this we want to save inside of the shader folder. This one here. And the name should be liquid. This shader is going to be for water and for lava. And the name should reflect that. Now click on open, create, and then we have a shader that we can work with. First of all, I want to deform this water so we are getting waves. And that happens inside of the vertex shader. I want to look at the water. That's a bit zoomed in. Righty, there we can see the water reasonably well. First of all, I want to get all of these vertex position of these vertices. That we can do via vertex. This covers every single vertex. And to that, we want to add a value. This has to be a vector 3 because we are working in the 3D space. And then the output is going to be the final vertex that we are displaying. At the moment, these numbers are 0, 0, and 0, so nothing really happens. However, if I change this for the y part, for example, to 20, then we're moving all of this up, although this I don't want to do at the moment. All of these numbers should be 0. These numbers should actually come from a texture. And to get that texture, we are going to need, First of all, a texture 2D parameter that I want to rename to wave texture. This in just a bit is going to become a noise texture. To sample it, we need a texture 2D node where we are getting the sampler port. This I want to connect, and then we are getting a vector 4 out of it, where we have RGB and alpha. Since the noise texture is black and white, RG and B are always going to have the same value, and alpha is going to be 1. In our case, we just want to have one of them. In my case, I'm going to go with red. And then at the moment, nothing happens, because inside of this texture parameter, we don't have a texture. For that, you want to have the water selected, and now you should have shader parameters, in which at the moment we have the wave texture because of this texture 2D parameter. In there, I want to create a noise texture, and if I click on that, I want to create some noise using fast noise light. And then we're getting a noise texture. Usually what people go with for water is cellular, and then inside of fractal, you go with none. That way, you're getting something that looks kind of like waves, although it's a bit of a stretch, but later on in the game, it's going to look better. You can zoom in and out. I think something like this is going to look okay. I guess we can play around with this later on. For now, let's make it a bit less strong. This is still very difficult to see, but now, for every single vertex inside of this water texture, we are moving it up and down by a very small amount. At the moment, this amount is so small that we can't really see the difference. The white color also doesn't help. To make that a bit more controllable, I want to clean things up just a bit and then add another parameter, which is going to be a float parameter, where we are setting the wave height. To use that value, we have to simply multiply it with the output we are getting from the sampler port. Connect this value, and then add it to what you're adding to the current vertex. That way, inside of the shader parameters, we don't need the noise texture anymore, and now wave height at the moment is 0, which means we don't add anything. But if I increase this value, you can see in the preview that we are adding more and more to it. And if I increase this value a lot, you can kind of see that we are getting waves, although still very hard to see because it's all pure white. I think at this point, what we really should be working on is to give all of this a bit of color. For that though, we at the moment have a problem. Inside of the vertex shader, we're getting the height of every single vertex. And later on, I want to have two colors. If a vertex is really tall, it should be more white. If it is really low, it should be more blue. That means we have to get information from the vertex shader to the fragment shader, which we are going to do via a varying node. In this case, we are needing a varying setter, which at the moment can't do anything. To make it do something, you want to manage your varyings and add 1. In my case, I want to create a vector 3 that I called wave_texture. And this has to go from the vertex to the fragment shader, which is really the only way we can go. There are not that many options. Click on Create, and now inside of the varying setter, we can get a wave texture. The value I want to get here is the texture 2D node. And then we can go to the fragment shader, add a varying getter, and get the wave texture. Once we have that already, we can connect it to albedo, and then we can see a bit better what's going on. So now, the higher up we are, the whiter we get, and the further down we get, the blacker things are. And to make this a bit more visual, let me change these values. They're kind of hard to see, but if you look at the preview, this is our default, and if I make it stronger, the whiter areas are pushed out more, and the blacker areas stay down. To get the proper colors, I want to add 2 color parameters, which means I want to have color parameter. The first one, let's call it color A. And besides that, I want to duplicate this and then get color B. Color A is basically going to replace the white color. meaning the more white we have, the more of this color we want, which we get via a multiply vector 3 node. This one here. And effectively, I want to multiply the current color with the wave texture. And this at the moment should be albedo, which at the moment is going to be black because this color is black by default. But now, inside of the inspector, if we change it to something like blue, that is looking kind of like water, then we are getting a fair bit closer to water. Still not amazing, but we are making progress. In just a bit, I'm going to change this color to white because the higher parts should be white. But for now, I just want to illustrate how it works. And having a non-white color for that would be better. Anyway, next up, I want to have this color where we have the black bits. The problem is for that, we can't use multiply. At least not right away. Because when this value gets to 0, we are always getting black. It doesn't matter what color we are multiplying it with. Instead, I want to add another node that is 1 minus for a vector of 3. That way we are inverting this texture. So originally, where we get white, we get black, and where we get black, we're getting white, which makes it much easier to use this color parameter. Or in other words, now we can add a node and multiply a vector 3 down here. All we have to do is connect these two, and then the darker this area gets, the more of this color we should be getting. Although we have to find a way to combine these two colors, which ultimately is very simple. We just have to add two vector 3s together. Vector 3 add, then we want to have the first color, add the second color, which at the moment is black, so no change. And this is going to be our albedo output. And with that, the second color, let's go with something visible, should be red. And now we are combining the different values. For actual water, this should be blue at the bottom, something like so. And color A should be something much brighter. Let's go with a whitish color. And with that, we are making some progress. This is kind of, with some imagination, looking like water, but we still have to add a few more things. Welcome back. In this part, we are going to animate the water and make it look a lot less horrible. Now, at the moment, we do have something, but this doesn't really look like water. So let's work more on the shader. And the color itself is fine. The issue we have at the moment is that the noise texture doesn't really work for the water. And that means we have to work inside of the fragment shader. Let me add as much space as I can, like so. This wave texture defines where we're getting the blue and the lighter blue colors. And if you update this noise texture, this updates in real time. So we can do things like that and get a different kind of effect. So you have to kind of find a right kind of value that looks good. Also, what we can do with the subdivisions. At the moment, we have 300 and 100. And I think what would be much better, I guess for both sides, we can go with 300 and 300. And that looks a little bit better, although not that much of a change. What is really going to make the difference is the stuff we are doing inside of the shader. Effectively, what we have to do is to modify this texture to D a little bit more. The way to start with that is I want to add another node, and this has to be a vector operation. Via that, we don't want to add things, we want to get the power of this texture to D, so drag it in there. And then we can take the power, which I think should be a float parameter. I couldn't really think of a good name for this. I went with density. You see in a second what this one does. But for now, I want to have for the hint a range. This should be 1 at the very least, and then going all the way to 4. The default value should be 1. This value I want to drag in there, and now we're taking the power of the vector. This is giving us another vector that is going to be much more concentrated. Or effectively, if you're looking at this texture, if we're taking the power, we are giving it a lot more contrast, which I think is actually a much better name. This should be contrast. From that value, once again, we're getting RGB, and you want to take one of those values. Since we are working with grayscale, it doesn't matter. Let me take green. And then, right now, nothing happened. That is because we are taking the power of 1, which doesn't change anything. However, if I now go to shader parameters, we have contrast. Via that, I can make some changes, which is still very hard to see. And also the color isn't affected at all. That is because we are still getting the original texture inside of varying. But instead, this should be this texture with the power applied. That way, if I now do the contrast, we can control much more precisely how much of this top part we want and how much of the bottom part we want, simply by taking the power. And that is giving us much better results. So something like this is looking a lot more like water. I think we do have to work on the colors a bit more. This shouldn't be so blue, should be more like a whitish color. And color B should be a bit lighter. I know, just play around. Once we're animating this, it's going to look a bit different as well. On top of that, what we can do at this point, before we're animating, is change the alpha value. For that, all we have to do is add another float parameter, which we can rename to alpha. This one is super simple. We just have to connect this node to alpha. And then inside of the shader parameters, we're getting the alpha value. Now for that, you definitely want to set a range. We want to go from 0 to 1 with the default value being, let's say, 0.9. And I think this could even be a bit lower, 0.8 maybe. This is something you really want to play around with in the game and just see what looks good. There's no universal answer, but inside of the game, this is kind of working. Really starts to look like water, which is a massive improvement. But still, it's not animated for that part. Back inside of the shader editor, we want to work inside of the vertex shader and effectively hand through this texture. Or in other words, when we are sampling from this texture via this texture 2D, we can animate the UV, meaning we are taking different parts of the image, and this we are changing very gradually. For that, we want to add another node, UV bunk. Via this, we can pan the UV. We just have to connect it, and then we can change the scale and the offset. We only care about the offset, and if I change this value, we are animating things. That's pretty much it. Although by default, this value should be 0. To get the values for this, I want to add another node, which is going to be the time. If I connect that to the offset, then we are getting water, but it's not looking good. So let's not do it right away. Instead, I want to have another float parameter, which is going to be the speed. This I want to multiply with the time, so add another multiply for a float, get those two values, and then we can work with the offset. Once we have that, you want to look at the shader parameters. In there, we have the speed, which should be a really low value, let's say 0.01. Then you are getting something, although it's still not looking great. Now, one thing, if you look at this bit, we have a really weird effect. That is because inside of the wave texture, it should be seamless. Makes all of this look much better. And this is definitely an improvement. So you could trick yourself into thinking that this is kind of looking like water. But still, it's not perfect. The one additional thing that I want to add is a vector2 parameter, which is going to give us a direction. This I then want to multiply with the speed, which means I want to have a multiply node for vector2s. Down here, the first part we're going to get from the direction, and the second part we are getting from this bit. This is then going to give us our offset. Once you have that, you can give it a direction. If I set this to 1, we can go this way, and if I add 1 for y as well, we can go another way. And then you kind of want to move it along with the river, or really whatever you think looks good. In my case, I think at the moment, it's going this direction roughly. So let's reduce x to 0.5. Let's try 2.5. And that is looking mostly all right. And yeah, definitely coming together. So I am reasonably happy. The one thing that you could be doing here is that this direction should be normalized, because right now, if this is 2.5, we are changing the speed. But I think in practice, it doesn't really matter. If I try to run the game, this is looking close enough to actual water that I don't have to worry too much about it. So let's have a look. And definitely starts to look like water. The major thing you want to do at this point is play around with these parameters to get something that looks good. The really important ones are the contrast. So in there you can get more or less of the top part. And you can work with the wave height. That way, if I look at it from a different angle, we can make these waves a lot taller. Although you really want to be careful here. Shouldn't be too tall. And well, with that, we have some very basic water. And this is definitely too much of a wave height. Let's go with 5. For a basic project, I think this is enough. When you're working with water, you can refine things a ton. But I think for our purposes, this is fine.